In stimulation sfemg performed with an intramuscular needle cathode, one sometimes observes an intermittent shortening of the latency of the action potential. When the stimulus intensity is increased, the potential is seen with the shorter latency position. This phenomenon is called the Axon reflex. The jump in latency is explained using this schematic. The terminal axon has two branches that are close to the stimulating electrode. At low intensity stimulation, only the branch close to the stimulator is depolarized. The action potential propagates antidromically to the branching point and then down the second branch, which generates an action potential in muscle fiber number 2, close to the recording electrode, time-locked to the stimulation. When the intensity is increased, the second branch is stimulated directly. Because the segment of axon between stimulation site and the motor end plate is shorter, the action potential latency is less. The jump of action potential between these positions can be seen quite easily by varying the stimulus intensity. Latency to fiber number 1 is not affected. Here is a recording from two muscle fibers innervated from the same axon, obtained at low stimulus intensity. It is sometimes subthreshold, and hence no action potentials are seen. At intermediate intensity, the responses jump back and forth between the two positions. At higher intensity, the potentials are seen at a shorter latency. The stimulus intensity is suprathreshold, and we see the potentials on all traces. In the next recording, observe the latency shift in the potentials as we vary stimulus intensity. When measuring jitter with intramuscular axonal stimulation, it is important to recognize axon reflexes, which should not be used for jitter analysis. Instead, the stimulus intensity should be adjusted to give a stable signal at one of the positions of the action potentials before analyzing the signals.